Alrighty, the last topic that we're going to discuss in this chapter has to deal with codominance. And codominance means that you have alleles, but neither one is really dominant over the other. And if both alleles are present, they're both going to have a say in what the phenotype of the organism looks like. An example of that she gave you in the book was snapdragons. You can have red snapdragons and you can have white snapdragons, and then if you breed them together, they will produce pink ones. And so it's not that it's going to be only red or white, there is an intermediate. And that very thing is true in blood types with people. For blood types, we have two alleles just like we do for any other trait, but there are three possibilities. You could have an A, you can have a B, or you can have an O. Now, the A and the B are codominant. That means they're equal to one another. One cannot overpower the other one, but the O is always recessive. Now, you've probably heard of blood types before, and so if you have type A blood, that means that your genotype for that could be either an AA or an AO, because the A is going to overpower the O. The O is recessive. If you have type B blood, you could have two B alleles, or you could have one B with one O. AB blood just means that you have one of each. Type O blood is recessive, and so therefore that means that you're going to have two alleles both for an O. The other factor that comes into play with blood is called an RH factor. And it's either positive or negative. You may have heard people say, oh, I'm O positive or I'm AB negative. The RH factor is called RH because we first learned about this factor in a rhesus monkey. And so RH comes from the name of the rhesus monkey. Again, two alleles for that. The positive is dominant over the negative. So if you have a positive blood type, your genotype could either be two pluses, or it could be a plus and a minus because the plus is dominant. If you have a negative RH factor, then both of your alleles are going to be negative. So the example I'm going to do today, again, is not in your book. It's an additional example, so you want to make sure you catch this. So a woman with type A blood marries a man with type B blood. Both the man and woman have one parent with type O blood. The woman is heterozygous in her RH factor, and the man is RH negative. And so what we want to know is what type of blood types could happen if these two get married and start having children. What kind of offspring could they potentially have? So what we need to do is just the same type of thing that we have done before when we've done a dihybrid cross. We're going to look at the woman first. She has type A blood, and so we have to have two alleles for her. And it does tell us down here that both the man and the woman have one parent with type O. Now we know if you have type O blood that your alleles are two O's, so that means they had to get an O from one of the parents. Okay, so the woman is going to be a type A, but she's got to be carrying an O. And we know that she's heterozygous in her RH factor. So that means she's going to have one plus and one minus. So her blood type is A positive or A negative? Which one is it? Hopefully you said A positive because the positive is dominant over the negative. Okay? Now, the man, on the other hand, he is type B blood, but he also has a parent with type O, so that means he's going to have a B and an O, but he's RH negative. Negative is the recessive trait, so that means he's going to have two negatives. All right, so let's look at this and let's see if we can figure out what possible blood types of the children would be. Now, for the man, let's do the man first because he's actually going to be a little bit easier. For the man, the B could go with the negative, or the O could go with the negative. I mean, there's no other combination, right? I can either have, I'm going to put the man down the side, so I'm going to have a B with a negative, or I'm going to have an O with a negative. That's what he could potentially give to his offspring, because he's got to give them one from this set and one from this set. So a B with a negative or an O with a negative. Okay, so that means I'm going to have 2 rows going across here in my Punnett square. Now, what could the woman potentially have? Well, the woman could give an A with a positive, or she could give an A with a negative, right? Because it could go either way. She could also give her offspring an O, and she could give an O with a positive, or she could give an O with a negative. So this Punnett square isn't exactly square, it's more rectangular, but what it does is it's going to give us all the different possibilities for both the man and the woman and their offspring, okay? So the woman has 4 possibilities because she's heterozygous in this, but the man only has 2 possibilities because he's homozygous in one of his traits. So what we're going to do now is we're going to go through here and we're going to figure out what the offspring could have, same as any other Punnett square. So here, AB with a plus and a minus, an AB with 2 minuses, a BO with a plus and a minus. On this one, you want to make sure that you do put the dominant trait first, just like we always have been before. Here I'm going to have a B and an O with 2 negatives. Down on the bottom one, they're all going to be all O's. So an AO with a plus and a minus, an AO with 2 minuses, 2 O's with a plus and a minus, and an OO with 2 minuses. So what kind of blood type, what kind of phenotype is this going to end up with? Okay, I can look at this and I can determine what those phenotypes are because I know that A's and B's are codominant, right? So this offspring is going to be A, B, and positive is dominant over negative. So that offspring is going to be AB positive. What about this one? Well, it has 2 negatives in that one, and since that's recessive, so I can also have an AB negative as a possibility. What about this? What blood type is this? Well, if you remember, O is recessive, so this is going to be B, and positive is dominant over negative, so I'm going to have a B positive from this one, and this one is going to be what? Yeah, that one's going to be B negative. Now let's look at my second line. I have an A and an O and a plus and a minus. What's that give me? Well, it's going to be A and positive. A positive. What about this one? A negative. And then over here, my last 2. I have 2 O's, so it's going to be type O. So it's going to be O with a positive. And this one's going to be O with a negative. So this one didn't turn out pretty, I guess you could say, as far as being able to group anything together because of this codominance. So I have equal possibilities of all of them, AB positive and AB negative, B positive, B negative, A positive, A negative, O positive, O negative. So really with this particular cross, I end up with every single blood type possible just from one set of parents. Not super common probably, but it could happen with this particular cross. What would the percentages be? Well, for each one of these, it would be 1 out of 8. And if you go ahead and do the math on that, that comes out to be 12.5% for each one of those. Okay? Now, probably the ones you do aren't going to be quite that complex, but the principle is the same. You still need to look at the 2 specific traits. It's still a dihybrid cross, just like we've done before. Figure out what all your combinations are, and then you can figure out what the phenotypes of the children can be.